Okay, we're gonna start on page 33. Page 33 in your packet. So we have a new online activity here. That says explore. We have a new section. This is 1-4. Says that right up here. It also has it on the bottom here with your page numbers. So after this section, we're gonna have a quiz. We're looking at Tuesday. We might even start Monday. We might review Monday and get started on the quiz and then finish up on Tuesday. That way you have a couple days to fix anything you would like before the end of the marking period. All right, so we have a new I can statement. We also have a whole new slide presentation. So remember, when you are in your Clever, oh, that's not what I wanted. Oh my gracious. Oh, really? Okay, this is too much here. Okay. So when you are in your Clever, you click on the red McGraw-Hill app, you will come to something that looks like this. And when you click on review today, I started the 1-4 in your calendar, so we can click on that and view it. We're gonna kind of go rather quickly through this presentation because we really want to get through things today and tomorrow. Do you know why no two snowflakes are exactly alike? Snowflakes are made up of water molecules which grow at varying patterns and rates. Some snowflakes are very small in size, the smallest being no larger than the diameter of human hair. That's pretty tiny. All right. If a snowflake has a diameter of 10 to the -2 centimeter, diameter is a measure of length. Can length ever be negative? Length can be negative? No. Your length could not be negative. I could never say you are -5 feet tall.
I am.
It would not make sense. Okay? So what do you think a measure of 10 to the -2 centimeter might mean? Any ideas? What do you think, Logan?
5?
5? I think it's gonna be smaller than 5. I guess we're gonna find out. So we have a new I can statement. We need to change that. I can use the 0 exponent rule. So we're getting more exponent rules and the quotient of powers property. So we're going to go back and review our quotient of powers property. When we talk about quotient, what are we talking about? What is a quotient? We're talking about division. How do we show division now that we're big people? We show it as what? Slash. So we show them as fractions. So when we talk about negative exponents, like 10 to the -2, we're really talking about a fraction. Gary, he's had enough, quite obviously, so please stop. So how are we going to use those? We can apply the laws of exponents to expressions involving 0 or negative exponents. I can study an expression to note its occurrence of any 0 or negative exponent in order to be able to simplify it. Okay, so what vocab? On the right side of your page, you have 0 exponent and 0 exponent rule, negative exponents. What do you think a negative exponent might mean? I maybe just hinted to you. The negative exponent is going to be the part that's below the fraction. What do we call the bottom number in a fraction? The denominator. Well done. So what do you think a 0 exponent might mean? What if I had 2 to the 0 power? It wouldn't be just 2. Remember, we said just 2 is 2 to the first power. 2 to the 1, the power of 1. So it's not gonna be 0, but we're gonna find out what it was. I'm gonna let the suspense. So we've got a guess of 0, a guess of 1.
Let's say 1.
So what does it mean when a number has an exponent of 0? We're gonna explore that. So consider this expression, 2 to the third divided by 2 to the third. What do you notice about it?
They're both the same.
They're both the same. If we were applying the quotient of powers property, what is the result? 2 to what power?
1.
No, what's 3 minus 3?
Oh, 0.
2 to the 0. And you just told me the answer to this would be 1. So what is our 0 property?
1.
Exponent property gonna be?
I guess that.
1. You did guess that.
Second time. But
So if we were completing this table, this is 3 to the 0. Or 5 minus 5. So 3 to the 0. We know 3 to the 5th divided by 3 to the 5th equals 1, right? This is just showing us with our quotient property that anything raised to the 0 exponent equals 1. Put it away, I'm not stupid. Thank you. What does it mean if it's raised to the 0 power? What's it equal?
0.
No, not 0. It equals 1. Anything raised to the 0 property equals?
1.
Anything raised to the 0 power equals? 1. All right, so the pattern is they all equal 1. Anything to the power of 0 is 1. So without calculating, what do you think? 7 to the 0, 9 to the 0, 15 to the 0, simplify 2. Go ahead. 1. Excellent.
1, 1,
1, 1, and 1. So what does it mean when a number has an exponent of 0? It means 1. Hopefully we remember that now that we've said it multiple times. All right, negative exponents. Hold on, before we do that, we're going to skip ahead and not explore negative exponents first. We're going to continue to learn about exponents of 0. So use the 0 exponent rule to simplify expressions containing exponents of 0. Let's look at the card. Here's the word card that it gives you on page 33. Do you see where it says words? Any non-zero number to the 0 power is equivalent to 1. Then below that, you have the algebra written out for you. X to the 0 power is equal to 1 anytime that X does not equal 0. 0 to the 0 power would still be 0, because 0 divided by 0 would be kind of undefined, but okay. Numbers. 5 to the 0 equals what? You just need to write that into your notebook. What are we putting here? What does 5 to the power of 0 equal? 1. Excellent. All right, I'm going to turn to page 34. Please turn to page 34. So we need to look at why any non-zero number to the 0 power is equivalent to 1, and we're going to look at the pattern. So here is giving us the table that we have on page 34. The pattern in the table shows that you decrease the exponent by 1, the value of the power divided by n each time. By extending the pattern, n divided by n equals 1. So n to the 0 power equals 1. So let's look. Maybe, here we go. So n to the 5th power, they wrote that out for us. N to the 4th power, we have to fill in the n times n times n. We have how many factors of n? This is great review. There are 4 factors of n in n to the 4th, or n to the 4th power. How many factors of n in n to the 3rd power? 1, 2, 3. So we need to write 3 n's. Remember, factor means they're being multiplied. N squared, or n to the 2nd power, is n times n. N to the 1st power is simply n. What do you think this is going to look like? N. N divided by N. Hey, that's a great guess. So N to the 0 equals 1. We do know that that is also N divided by N. See how they wrote N to the 1 minus 1? This is 1, this is 1, so that also equals N to the 1 minus 1. Let me make that a little bit bigger for you. Wrong way. So those are the notes that you should have. Excellent. All right, so looking at that pattern, if we continue on, we have to know what these would mean. So which of these are equivalent to 1? Is 2 to the first equivalent to 1? It is? 2 to the first is a factor of 2 one time. So does 2 equal 1?
No.
No. How about 1 squared?
No.
A factor of 1 twice is 1 times 1. So does this equal 1? Yes. So I'm going to write that down here below where it says equivalent to 1. How about 2 to the power of 0? Remember, this is 2 divided by 2, which is 1. So 2 to the 0 is also equivalent to 1. 1 to the 0 power is also 1. Good. So we're going to write 1 to the power of 0 there. How about 0 to the 1 power of 1? This is just 0, right? If I have a factor of 0 one time, anytime I have a factor of 0, my answer is always going to be 0, because anything we multiply by 0 equals 0. How about 1/2 to the power of 0? It is also 1, right? This is like saying 1/2 divided by 1/2. This is 1/2 to the power of 0. Also 1. Okay. Now we're going to jump to example 1. So any non-zero numbers, I'm going to stop the share real quick. Any non-zero number to the 0 power is what? Is 1. So if m is to the power of 0, what does this equal? 1. That's how I would simplify that. That's not so bad. Okay. So if I were to be looking ahead slightly, I have just a couple that I can practice real quick. Do numbers 1 and 2. You have a minute. That's all you should need. It's on page 41. Page 41. Numbers 1 and 2. It should be real quick.
Done.
Awesome. Now hop back to page 35, and we're going to explore these negative exponents here. I know that really challenged you, didn't it?
Yeah. That one was like really hard.
All right. Here was your extra example. If you wanted to write it down, you can. X to the 0 where x is not equal to 0 is still 1. All right, negative exponents. I do want to hop back here so we can explore those real quick. It tells us in our packet that there's this online activity. Guys, shh. So we have to be able to simplify an expression with a negative exponent. If a cake is cut into 16 pieces, you serve half of the pieces to your friends. Each day you continue to serve half of the remaining pieces until one piece of cake is left. Complete the table to show how many pieces of cake are remaining each day, both in exponential form and in standard form. Okay, so 2 squared is actually what? What's 2 squared? What's 2 times 2? 4. What's 1 factor of 2? Simply 2. And no factors of 2 would be 1. This you don't need to write down, we're just looking at this together. So notice that 2 to the 0 is the last expression, which represents the one piece of cake left. So now, if we split that in half, we have 2 to the 0 divided by 2. How would we write 2 to the 0 divided by 2 in exponential form? 2 to the negative 1. How did you get negative 1? 0 minus 1. So remember, when we have 2 to the 0 divided by 2, this is a power of 1. So our quotient rule tells us that this is the base subtracting our exponents. So this is 2 to the negative first. Very good. Fantastic. All right, so if we divide by 2, it's actually going to be what? What's 1 divided by 2? 1/2. Very good. And then we're going to continue multiplying the thing by 2 again. So they divided by 2 here. If they divide by 2 again, what's happening to our exponent? It's getting more negative. So if I have 2 to the negative 1 divided by 2 again, this is really like 2 to the negative 1 minus 1. Remember, our integer rule says this is 2 to what power? What's negative 1 minus 1? No, it's not 0. It's getting more negative. Start at negative 1 and move to the left 1. Negative 2. So if I cut that half a piece in half, I now have a fourth of a piece, right, Jace? Make sure you're with us. So they're doing that over and over and over. And then it says divide by 2 again. So this is going to be 2 to the power of negative 3. So that quarter of a piece is now an eighth of a piece. And so on and so forth. So 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8. And 2 to the negative 4 is 1. What's 8 times 2? 16. So 1/16. So when we have a negative exponent, what's happening to our denominator? Our denominator is getting bigger, but our number is getting smaller. All right, so let's hop over to look at negative exponents. So beginning on page 36 now, we're on page 36. A negative exponent is the result of repeated addition. You can use negative exponents to represent very small numbers. So every time you divide by 10, the exponent decreases by 1. The pattern in the table shows that 10 to the negative 2 can be defined as 1 over 100 or 1 over 10 to the second power, or 10 squared. So let's start this table here. Oops. 10 cubed has 3 zeros in it. So 1, 2, 3. That's 1,000. Do you see where we are on page 36? Make sure you're filling in this table with me. 10 squared has how many zeros in it? 2 zeros. 10 to the first, that's telling us how many zeros is in it. We know that if we have one factor of 10, it's simply 10. What if we have 10 to the power of 0? What does that equal, guys? 1. We just learned that. We have to remember it. Now, this one's a little bit tricky. This is 1. It's not negative, but it's being divided by 10. Which means this is 1 over what? How many zeros are in the bottom now? 2 zeros, yes, 1 over 100. And how many zeros here? 3. So do you see every time it's being divided by 10? So we can show that on here as well if we want to. This is just filling in the table just like we did. 10 cubed, 10 squared, 10 to the first power, 10 to the 0 power, 10 to the negative 1 power, 10 to the negative 2 power, and 10 to the negative 3 power. All right, so now we are looking and reading those words. So any non-zero number to the negative n power is the multiplicative inverse. What do we remember about multiplicative inverse? It's a big word for reciprocal. That's when we were flipping the fraction. The multiplicative inverse of its nth power. So do you see how 10 to the negative 1 was the reciprocal of 10 to the 1? Do you see how 10 to the negative second power was 10 to the second, but the reciprocal of that? And same with 10 to the negative 3. Are you guys seeing those multiplicative inverses? That's a big word. All right, and here's the algebra they wrote for us. X to the negative nth is equal to 1 divided by x to the nth. And your number 7 to the negative third power is equal to 1/7 times 1/7 times 1/7, or 1 divided by 7 to the third power. All right, so let's continue on here. We've got a bit of time. Negative exponents. So how would we express then 6 to the negative third? We would have 1/6 to what power? The positive third power. We have to know this. This is our negative exponent rule. Here's the definition of a negative exponent. So 6 to the negative third expressed using a positive exponent is 1 divided by the positive exponent of that. So how would I write x to the negative fifth? What would I do? I'm going to write that over here. X to the negative fifth is equal to 1 divided by x to what power? We're on page 37, page 37. X to what power, guys? X to what power? This becomes positive. The negative 5 becomes positive.
5.
So our check then is right there on page 37. A to the negative fifth power is equal to 1 divided by what? 1 divided by 5? Or 1 to the a to the positive fifth power? Fifth power, not fifth hour. Huh. All right, so try this extra example here before I have you do one more. All right, so b to the negative fourth. B to the negative fourth is equal to what? How would you express b to the negative fourth as a positive exponent? What becomes my numerator?
1.
1.
I was gonna say that, but.
Now b is down here and my exponent is positive. So be careful. We have to understand this and remember this. All right. I would like you to jump now before we leave to complete numbers 3 and 4. So 1, 2, 3, and 4 should be done today. 1, 2, 3, and 4 on page 41 should be done today, which means we gotta really get to work tomorrow.
If it's an odd number, would it be negative for that? Odd number, for number 4?
You're still writing it the same way. These both become 1 over whatever that is to the positive exponent. So you're writing these as fractions, right? 1 over something to the something power.
8 to the negative.
Not to the negative fourth, but to the positive fourth. Good.
We have another 1 line. So 1 over 9.
All right, guys, we still have 5 minutes, so are we good to move on?
No.
Let's do it.
No.
So looking at example 3, I do believe, page 37. This is the same thing, but we have to know it in the opposite direction. So 1 divided by a positive exponent is equal to that base as a negative exponent. So 1 divided by c to the 5th expressed as the negative exponent is c to what power? The negative 5th power. Good. So that's what we're writing in there. And then express 1 div- oh my goodness, this is a negative 5.
Go to 1.
Instead of writing this, write it as 9 to what power? Negative 7. Excellent. Now you should also be able to complete numbers
4 and 5.
5 and 6.
Oh, 5 and 6.
So we should have 6 problems done before we leave today. So what is our base going to be here? Looks like the letter D. Because it's D to the 6th power below the fraction bar, that power is going to be actually negative.
So it's negative 6.
Mhm.
And then the next one is 10 to the negative 6.
Good. So make sure we get those. Get those.
I can pack up.
You still have 3 minutes, but take your time. Make sure you have 1, 2, 3, 4, 5, and 6. If you don't understand them, go back. Check your notes. Go back through the slideshow online.
My 500 word memoir starts.